Today on Orbital Dispatch, are we actually close to finding alien life? Here's what the science says. We will break down what happened and why it matters. Are we actually close to finding alien life? Here's what the science says. The question of whether we're alone in the universe is no longer just philosophy. It's an active area of scientific research with real data behind it. And the honest answer is more interesting than either yes, definitely, or probably not. Intro. Welcome to Orbital Dispatch. I'm not going to tell you alien contact is imminent, and I'm not going to dismiss the search either. What I'm going to do is walk you through what the science actually shows, where we're looking, and why the next decade genuinely matters. Section 1. The numbers behind the search. It starts with a thought experiment from 1961. Astronomer Frank Drake wrote an equation to estimate how many communicating civilizations might exist in our galaxy. You multiply together factors like the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, and so on. The honest problem with the Drake equation is that most of its variables are still poorly constrained. We're guessing at some of them, but it did something important. It turned a vague question into a scientific framework. Then, in 1950, physicist Enrico Fermi asked a blunter version. If intelligent life is reasonably likely across a galaxy this old, where is everybody? That's the Fermi paradox. We've had no confirmed contact, no verified signal, nothing that holds up to scrutiny. That silence is strange. But strange doesn't mean hopeless. Section 2. Planets everywhere. For most of human history, we didn't know if other stars even had planets. The Kepler Space Telescope changed that. Between 2009 and 2018, it surveyed a patch of sky and found evidence for thousands of exoplanets. The headline finding wasn't any individual planet. It was the statistical implication. Planets appear to be extremely common. Many stars host them. A significant proportion sit within the habitable zone where liquid water could theoretically exist on the surface. That's not evidence of life, but it does confirm that the raw ingredients, rocky worlds, the right distances from their stars, are not rare. That matters. Section 3. The places worth watching closely. Here's where it gets genuinely interesting. Some of the best candidates for life in our own solar system aren't planets at all. They're moons. Europa, one of Jupiter's moons, has a global ocean of liquid water beneath its icy crust. It's kept liquid by tidal heating from Jupiter's gravity. Where you have liquid water, chemical energy, and minerals, the basic conditions for life as we understand it, you have a reason to look. NASA's Europa Clipper mission launched in October 2024 and is on its way. It won't land, but it will analyze Europa's environment in significant detail. Saturn's moon Enceladus is similarly interesting. It actively vents water vapor into space, which we've sampled directly via the Cassini spacecraft. Then there's the James Webb Space Telescope. Webb is designed to study exoplanet atmospheres, looking for chemical signatures that might indicate biological processes. It's not going to confirm life, but it could find something that demands further investigation. That's a meaningful step. Closer. So are we close to finding alien life? Honestly, we don't know. But the search has never been better funded, better equipped, or more scientifically grounded than it is right now. We've gone from having no confirmed exoplanets to cataloguing thousands in 30 years. We have spacecraft en route to an ocean world. We have a telescope reading the chemistry of distant atmospheres. The silence from the universe might mean something, or it might just mean we haven't looked in the right place yet. Either way, the science is worth following. Subscribe CTA. If you'd like to follow it here, subscribe to Orbital Dispatch. New videos on space and science, no hype, just what the evidence actually shows. Main takeaway: the evidence is still evolving. Subscribe to Orbital Dispatch. Next, our next breakdown.